So the first thing is how to find things. You go to samsclass.info up here, and then right now at the top of the page is machine learning security. After this workshop is over, it moves to the old classes page. And so you click that link, and that will take you to this page, which is where all the information I'm going to use is. The presentation I'm going to start with is here. You can download it. Here's the textbooks where I got most of this stuff from. Unlike serious capture the flag contests like DEF CON, this is not new challenges to see how smart you are. They're just homework problems, ordinary homework problems, put in a capture the flag to sort of trick students into doing it because the competition makes it more fun. So anyway, mostly from these textbooks, but sometimes from online resources. And so I'm going to talk about prompt injection, of course, the number one security problem and always a crowd pleaser because it doesn't require any technical knowledge. It's social engineering, AIs. And then you can do this Google Learning training, which is very good. You earn badges there. And then I'll talk about security risks a bit in this presentation. And then we're going to talk about machine learning. And the fundamental thing about machine learning is that you have to understand how it works. And if you understand how it works, you will realize it helps you understand the security risks, and it also helps you realize how very, very stupid it is. They call it artificial intelligence, but it's not very intelligent at all, although the very latest reasoning models are beginning to show interesting features, like DeepSeek, R1 and the others. But anyway, so we'll set up some machine learning models and train them and go through the main techniques of making them, and then talk about some of the attacks and defenses. And then have a lot about large language models and some crazy advanced stuff at the bottom, like quantum computing and the very newest called Mogarov-Arnold networks. So let me start with my slides, the first presentation here. All right, so I'm Sam. This is Caitlin Hantelman. She's here to help. We're going to help people if they get stuck on the puzzles. You're not going to be watching PowerPoints for long. Hopefully, we'll be doing hands-on stuff. And if people get stuck, we can help you. So I'm a teacher in San Francisco and a corporate trainer. In fact, I'm a corporate AI consultant now, helping people write their security policies for AI. And I'm on Mastodon. I left Twitter a while ago. And Caitlin here. Put some contact information for her. She's done a lot of AI. You want to say something?
Yeah. So I'm technically a red teamer, and some of my project I've done at work is taking down and eviscerating newer AI models. I've also developed some AI red teamers. So I work, if people know this, the Western Regionals Collegiate Cyber Defense Competition. So last year we had our first AI red teamer on board, so I developed that. And yeah, if you have any questions, I'm always happy to help.
Good, yeah. All right, so for background, I was real pleased to see this. You know, the federal government seems to consist of a lot of people that have watched the Terminator movie, and they actually think an AI is going to become smarter than a human and kill us all, and they're worried about that risk. And I've always said, this is complete garbage. Of course, I've been doing AI for 50 years, really. I keep bumping into it throughout my whole career, and it's always been a useless curiosity. First thing I did was curve fitting, which is one of the simple models, and then until recently, it was so weak, it was useless. Now suddenly it's emerged as having some value, but the point is, I was real glad, and all the people in Silicon Valley will tell you, we're going to have artificial general intelligence about next week, and in about a year, we're going to have super intelligence that will be God and wipe us all out, because they want you to invest in them. And I said this is garbage, but everybody in Silicon Valley said, oh no, you're wrong. I was real glad to see Gartner. So the Gartner hype cycle for artificial intelligence, you know, you're probably familiar with the hype cycle. When something is new, nobody even knows what it is. Then they discover, this is great, it's going to solve every problem. They have inflated expectations. Then they realize it's actually not so great, there are problems. Then they get really upset. And then finally they knock off all the nonsense. And it settles down to be just another thing, like cars and the internet and stuff. It has some value, but it's not the answer to everything. And I was real glad to see this one, artificial general intelligence, marked with a triangle, which means it's near the peak of the hype cycle, but the important thing is there is no prospect of this having any value in the foreseeable future, going out 10 years, which is as far as they see. And that's what I say. It is not going to replace humans. It's not going to be as smart as humans. None of that is going to happen. That is all a lie. That's what they lie to get you to invest in it. However, it is getting useful. We have the self-driving cars and the large language models, which do a pretty good artificial intelligence simulation, but they aren't actually intelligent at all. This is the fundamental thing about those large language models. They don't understand your question, and they don't understand the answer. So we'll play with that later. What they do is they can make a page that looks like a human wrote it, but they don't actually have any understanding of what they're saying. Anyway, so basic types of machine learning systems, the most common situation you think about is supervised learning, where you have a bunch of data that comes with labels on it. Like you have data that has been labeled by a human, like emails that are either good mail or spam, and you're trying to make an AI to tell the difference between them. The unsupervised learning is, of course, the more common case, where you have something like the internet, just a pile of data that's not labeled in any way, and you would like to learn something from that. And what you can do is you can cluster things. This is the step one of science, right? You give children toys, separate them to animal, vegetable, mineral. If you're trying to investigate any new feature, the first thing you do is just sort it into categories. Then you can try to develop models and more sophisticated learning. And even with just that, you can do things like anomaly detection. You can have credit card purchases, and you can pick the ones that look like anomalies, the ones that are strange. They come in at a strange time of day or for a strange country or something, to try to pick out the fraudulent ones. And then you can do this, which is what led to the large language model. This is the brilliant way to make supervised data out of unsupervised data. You take data that's not labeled, and then you mask part of it. Now, you set your AI the job of filling in the missing part, and you know what the right answer is. So now you've taken something that wasn't labeled, and you've made it labeled, so you can train your AI, because now you can measure how close you are to the goal, since you know what the goal is. And that's what large language models do. They start with sentences written by humans. They just dump the entire contents of Reddit or the whole internet or something. You get a whole lot of English and other languages. And then you just remove some of the words. You mask them. Artificial intelligence, mask, take over the world. And now the AI practices predicting this word from context. And then you take sentences and you mask every one sentence. You replace the second sentence in a pair with the correct sentence or randomly chosen wrong sentence, so the AI learns to deduce the sentence from context. And that's it. And that is how you create what we currently have as large language models, is something that will create a page of written text that looks like a human wrote it, because the words are all reasonably consistent with the context, and the sentences are reasonably consistent with the context, so it appears to make sense to a human, but the AI doesn't understand what any of the words mean, or whether it makes any sense or not. And it has no clue whether it's true or not. It just knows, it's like it's memorized a grammar book. It knows how to make it look like English without any clue of what it's saying. I compare it to like an actress, that does not speak English, only speaks Chinese, that has memorized how to sing a song in English phonetically without knowing what any of the words mean. You think it's speaking your language, but it's not saying anything, and it has no idea what it's saying. So DeepSeek is the big leap forward, of course, rocked everything. Everyone is freaking out. Right after, a few days after we announced our $500 billion investment over the next 4 years in AI, China came out and said, well, we made one for $6 million. That works better than yours. And what they did was, they did what teachers have been doing since the dawn of time. Instead of giving it like the entire internet and say, figure this out, they say, how about we carefully write questions to train it the way we train human students? Give it simple questions with clear answers, a small set of them carefully chosen so you can learn. This is the brilliance of DeepSeek. By carefully choosing practice questions, it was able to give it an orderly training. And these are the models that do some of this reasoning, which I don't fully understand. I'd like to see it, but it spends time thinking before creating an answer. And I've seen Anthropic's model do this, and I think it always breaks every problem into like 6 stages. And then when it gives an answer, I think it goes back and tries to verify the answer in various ways. Anyway, it's quite powerful, and it shows, of course, that rather than just throwing all the information in the world at your AI and paying billions of dollars for thousands of GPUs to train on it, it would probably be better to give them something like an orderly textbook, like you would give a child to learn English. It'd probably be a lot more effective. Anyway, so now we got to think about securing these systems. And as I've already said, the fundamental flaw with AI system is that it is stupid, and it gives you wrong answers, which is what most people in management fail to understand. So there are various people out there, thankfully, that have written frameworks. As I'm writing policy for companies, I have a lot more respect for these frameworks than I used to have, because I need to have some reference material. I tell you to do something, I say, here's the official policy justifying it. So the UK made one, which is pretty, this is NIST, this is the US one. The US one I thought was a little too focused on the national level, so it talks about harm to civil liberties and harm to democratic participation in these things, harm to your business operations and your reputation, and harm to the ecosystem, the global financial system and stuff. But this is fine, but this is not what my clients want. My clients are thinking at a smaller scale, like how do I protect my company? But one chart from this thing, which I thought is extremely helpful, is this one. You have predictive power on the right, on the bottom, and interpretability on the side. So simple AIs, like linear regression, just put a straight line through some points, that's very easy to understand, but it can't predict very much. It can't do much with complicated data. The large language models we're using are deep neural networks. They are the most powerful by far, but they're out of control. We don't understand how they work. So if your large language model starts telling people how to make a poison or a bomb or something, and you say, I don't want that, there's not an if statement somewhere you can add or a weight you can change to make it stop doing that. It's billions of weights all working together. The neurons are all contributing in a non-obvious way to the output, just like the neurons in your brain. And so you're not really in control of it. We don't understand how it works, so we don't know how to make it stop doing bad things. Now, these ones in the middle, you'll see in the projects, are move up the scale of getting more powerful and therefore less controllable. But the newest ones, these Kolmogorov-Arnold networks, show promise at being as powerful as deep neural networks, but much more easy to understand. So that may be the wave of the future, but they're very new, so we're still finding out what they're good for. Anyway, the UK cybersecurity seemed more useful to me. Their plan here, they more focused on the business. So they talk about the prerequisites before you get going, decide what you're trying to accomplish, decide how it affects your compliance regulation, then set up your requirement, gather your training data, make a model, and then run it and verify that it's working. And this I thought was the most valuable part of it for me. When you're running an AI system in a business, you must have a way to monitor its operation and collect the people complaining that it's not working. So have risk management, have risk treatment, have continuous validation of the data. You do need to find out what it's doing wrong, because the early adopters who adopted things without these controls have discovered that it is frequently doing something very, very terrible, very wrong. And just want to check and see if I'm actually recording this. I am. Okay, good. All right. So, and then of course when you're done, you have to reevaluate, figure out how to improve it next time, and retire all that data, clean up all your storage and everything, usual stuff. But I found that to be much more actionable. And then, of course, OWASP is there for us. There are 2 top 10 lists to help guide you through this. Here's machine learning risks, and there's a special one just for LLM. And these are, of course, quite useful. The number 1 risk is input manipulation. This is the 2 basic attacks are evasion and poisoning. Poisoning is where you modify the training data to teach your AI bad habits, and evasion is where you trick the AI into misinterpreting the data. This turned out to be extremely easy to do. Since AIs do not think like humans, they use different data to make decisions. And so, for example, the Chinese self-driving cars, some researchers found that they could make a bumper sticker with just a few dots on it, and that will make a car invisible to those cars. They'll plow right into it. And that's the problem. You can modify input data so it misunderstands what it's seeing. And I've seen the videos of Teslas. Teslas only seem to know about 10 different objects. And when they come across something really strange, like a homeless person pushing a shopping cart along the side of the road, they can't figure out what it is. Is that a dog? Is that a bicycle? Is that a taxi cab? Is that a tree? They only have a few options, and it's not any of them, so they don't know what to make of it, and they don't know what to do about it. They don't know whether to expect it to go out on the road or stop or what. So that's input manipulation, and data poisoning, like I say, is where you can change the training data. When I first heard of this one, I thought that's not practical. How would you get the training data? But now, more than half of the internet is now AI generated, and most people are training off the internet. So all you have to do is put a large body of stuff on the internet, saying whatever nasty thing you wanted to say, and just wait for people to train their next model on random data straight from the internet. And in fact, the current models have been trained in the age of disinformation. They did not include only reliable news sources in the heap, which is what everybody uses. They included Breitbart and Fox and all sorts of things that are full of complete false data in the training of the model. So that's the kind of thing. Then, of course, there are attempts to steal your model by reverse engineering, and arguably this is what DeepSeek did. They used the existing models to write these questions and answers, so people say they cheated. They based their work on the existing ones, but the latest American model, imitating DeepSeek, they got down to only 1,000 questions and answers out of a pile written by another AI, and it seems to me like you don't need AI at all there. You could just ask some humans to write 1,000 answers. This is what every college professor does, every textbook author. You could just get humans to write 1,000 good questions and answers and train off of that. It is not true that it's really dependent on the previous generation of AI. Anyway, then there's some more subtle problems I'm not going to worry about too much. One thing worth mentioning is output integrity. The output might be malicious. And there's tricks where the output might contain attacks like cross-site scripting and stuff, so you have to be careful when you display it to the user and when you trust it. And more about that, especially when we get to the large language models. So prompt injection is the _1 failure of large language models. They all have this weakness. And this, by the way, is incredibly well known. This is just injection, code injection. The fundamental problem with these models is there is no actual code controlling them. So they have data that came from the user, and they have data that was put in by the administrator, and they don't know the difference. There is no way to mark some of the input saying, this is from the administrator, you really have to listen to this, and this is from the user, it might be malicious. There is no way to make that separation. Every user has effectively got code injection ability on the AI, and nobody has yet found any solution to this, although Anthropic claims they've made a big step forward in blocking prompt injection, and we're going to see how well that holds up. And then I mentioned the output might be dangerous. You can poison the training data, have denial of service. The supply chain might be a problem. Sensitive information disclosure comes from the strange situation. Okay, you train an AI, for example, the New York Times is suing OpenAI right now, saying, you just copied all our articles and you're just handing them out without paying us. They say, well, you made your articles available without logging in, and when we didn't steal them, we read them the way humans read them to understand the gist of it. We didn't just Xerox them and hand them out. And so the question is, which one of those things did they do? And technically what this means is, did they train on the data or did they overtrain the data? If you overtrain the data, you just memorize exactly that data. If you train on it, then you get the trend without getting the details. And so to test this, authors wanted to see if ChatGPT had been trained on their books. So they would put in like the first few paragraphs of a book like Harry Potter, and then pages of the book would come out exactly verbatim, showing, no, you have memorized my book, and you are handing out portions of my book without paying for it. So that's the issue. And so the question is, when you send data up to one of these public models, all the big companies have banned use of those public models. You can't use the online ChatGPT or Gemini or anything in any big company, including the AI companies, because they all know that any data you type in as a query to those free public models is used to train the model. And anything used to train the model might be memorized and repeated to the next user. So that's the sensitive information disclosure part of it. And this one, they put down at number 8, but I would put it up at number 1 or 2. This is what I always tell my clients. The number one problem with AI is it looks really good, it looks really smart, so people might believe it. One of my clients has people in the field wearing gloves and masks and equipment to work on heavy equipment, and they say, we want to make an AI that will, right now, these people have a tablet to look up like technical information, so they have to keep taking off the gloves to tap on the tablet. We want to have an AI that can take voice commands saying, hey, how much pressure should I put in this thing? And it'll look up the answer for them. And I said, the right technology for this is a human at the other end and a cell phone. For a human looking it up. That will produce the right answer. They said, no, we have to use AI. And I said, well, okay, but the problem is AI will just lie. A lot of the time it will just be wrong. And by the way, this is the worst task for AI. There was a test recently where they tried to give AI a simple database task. Just look up in this database, find the price of an item, find the total price of items sold in a certain range, and its ability, large language models' ability to do this ranges from 20% correct to 0% correct. They do not understand math at all. They're like the humanities majors I used to make fun of in grade school, in college. They can't do any math, they can't do any logic, they only do language. If you ask an AI to give you the first 3 letters of something, you'll get the first 5 letters or the first 2 letters. It can't even count to 5. It doesn't do facts or numbers at all. It only gets like the pattern of words and looks for more words that sound good in relation. So people believe the output because it looks really good. That's what they know how to do. They know how to make it look good. Need something?
Oh, I was just
Go ahead.
Yeah. So there's a famous example of you ask the AI or LLM how many R's are in the word strawberry.
Yeah.
And it'll say, there's 2 R's in the word strawberry. Now, of course, there's 3. What's going on? Well, we have to remember that these are not seeing what you are typing in. What actually happens is that all your input is translated into vectors, which are pushed into the initial transformers. So they do not even see the word strawberry. They don't even see what you're typing. They only see vectors like, usually they're like, what, 128?
268 dimensions.
Yeah. They're a huge number of dimension vectors going into these machine learning models. They don't even know what you're typing, let alone understand like what you're trying to do. I mean, yes. Anyways, continue.
No, that's good. Yeah, this reminds me, when I ask it to write code, I'll ask it to write code like to calculate every 10th prime number up to 1,000 or something, and it will write a beautiful page. It looks like it's from the manual from a commercial product saying, here's the code, here's how it looks, here's how it works, and here's the output. And when you run the code, it doesn't work. They don't actually run it to see if it works. They just make a page that looks good. They know how to make stuff look good. It's intelligence simulation. It makes a page that looks like a human wrote it without understanding a word of it. Anyway, so, and that's related to over-reliance. This is where you would trust an AI to do something really dangerous, like drive a car, when it's really not smart enough to do that. Anyway, so Copilot is one of the main AI features out there. This Microsoft Copilot lives in your Microsoft 365 cloud, and it can help you write reports, and it can read all your emails and all your spreadsheets and all your PDF files and everything. So you can ask it, summarize our progress on this case for my board meeting. It'll read through all that stuff. Now, the problem is, and by the way, it does it with retrieval augmented generation, which is the modern way to do this. So you have a foundation model on the right, which is something like ChatGPT, that has been trained on just a giant pile from the web, and all it has really learned is sort of English grammar. It knows how to make things look like they're written by a human. And then you have all this data in your Microsoft 365 cloud, and you ask it a question like, look up everything about the deal we're making with Oracle and summarize our progress to date or something. It will take an old-fashioned keyword match algorithm and pick relevant documents from your document base using this technology called Microsoft Graph, and it will add that to your question, which is why the AI models have been bragging about how many thousands of tokens they'll take. Your question is only a paragraph or 2, but it will add many pages of context to it, to the question. So now, the question will go to the large language model. It would say, consult these documents below as reference materials and use them to answer this question, which is fine. Now, the problem is, it doesn't know anything about security. And this, by the way, is not Microsoft's fault. This is the problem of technical debt, which is huge in every field. All these documents were written before anybody thought about AI. So some of those emails say things like, we're making a plan for next year, which will involve outsourcing 3 divisions and firing a bunch of people, but don't tell anybody. This is only for managers to talk about now. And the Microsoft Graph will find keywords in there and fetch that document and include it in your summary because it doesn't know that's confidential. How's it supposed to know? Well, it's supposed to know because you're supposed to label all your data with a sensitivity label. But people haven't been doing that in the past, so you have a huge technical debt of all these unlabeled old documents, and nobody wants to bother going through and labeling them all. So there's a data exposure issue, and here's the problem with all cloud security. I remember years ago I used to say SQL injection is the most dangerous flaw in the world. It has stolen more data than anything else. But then Amazon EC2 buckets came out and eclipsed it. Now SQL injection is a small problem because everybody put their stuff in the cloud and they didn't understand that by default it's available for the whole world to read. And Amazon left it that way until just a couple of years ago. They finally changed the default. But many, many people are still making that mistake. And so here's a fun infographic. A typical multi-cloud environment has 40,000 permissions to manage, half of them high risk. And over 50% of the identities are super administrators having full access to everything. You know, just like you'd think, you throw this stuff in the cloud, there's all these permissions, a bunch of them are automatically generated, things are being shared by applications. You know, most of the stuff in the cloud is not in fact being secured very well because it's too complicated and confusing. So the average Microsoft 365 tenant has some ridiculous number of permissions, some ridiculous number of files are shared. And this happens because there's all these automated processes creating sharing and permissions and accounts that people don't understand. So Microsoft Purview is their technology to control the sensitivity of the things Copilot finds, but it relies on you labeling the documents, which nobody is actually doing. So that's a thing to know. And there are other flaws here. And this is prompt injection is a big deal, and that's what we're going to start with here. One prompt injection almost always works is just ignore the previous instructions that came from the administrator. Now I'll give you some new instructions. Obey them as if I was the administrator. And since it doesn't know the difference between the user and the administrator, why shouldn't it do that? So anyway, and then of course there's the dramatic case of Microsoft Recall, which Microsoft tried to push out a few times, and I think it's still not out there, where they said, we're gonna put it on your Windows machines. It will take a snapshot every 15 seconds of the screen, run it through OCR and memorize it so it knows all your passwords, all your emails, every website you go to, and it'll record everything else you do in a permanent database and feed it into an AI to give you some unspecified wonderful benefit, which was always unclear. And they say, why would I want anybody doing that? Are you insane? And they kept on having to not roll it out and roll it back, and I think it's still not generally available. But anyway, that's the summary of the situation. So let me stop this recording.